Yes.
When you were doing trusses in that session,
Yeah.
how do you change the material of the truss?
Let us show you that. That's a really good question. Let's talk roofs, and then roofs within the trusses. And then we'll go from roofs and trusses to like joists, and then sort of funny roofs. Okay, a little bit of all those things. Okay, good question. Let's come back out and show you. Okay, so to put this in the context of a building, let's go ahead and, whatever. I'm just going to duplicate this up. Just to give myself a second floor that I'm going to put some roof on. So I got this. I am going to go through and just copy this to the clipboard. I'm going to paste it aligned to the selected levels. I'm going to put it, see if this is going to work. It's not. Because columns belong to the level above, not to the level below. So that's what's going to sort of mess with me on that. What I'll do is take that same right there. I'm just going to add a level 3 just so I have something to work with. Hopefully that's 10 feet or so above. Okay, now we can do it. Come back over to my 3D view and let's fix that. So I'm going to grab those guys. I'm going to copy. I'm going to paste them to level 3 now. Okay, good. Now we want to put some trusses going across those. So the first question is, trusses ultimately, they can really adapt to any shape. There's some standard shapes, and then we can adapt the top chord to really be whatever we want it to be. So trusses look like this. Under the Structures tab, you go out and find a truss, and you load in a family, really based more than anything on just the overall pattern of the chords, because the pattern's really sort of what matters. Within those patterns, whether it's kind of coming up as two different sides. I often choose a flat truss if I want it to have some funny weird curvature or something like that, because I really want one top chord that I'll mold to the surface, whatever it is. But you decide whether you have sort of two surfaces or one or two bottom chords, just depending on the shape you want. So I'm just going to put the flat truss on for now. And then I can go through and just snap it from here to here. Okay, so far so good. Now the problem with a truss, as many of you note, is that trusses are made up of all these kind of elements. And all these elements, the only thing it knows how to make trusses out of are the elements that are already loaded into the project. Okay. So if, for example, you want the chords, okay, to make something smaller, maybe the top and bottom chords are big, maybe all these little intermediate pieces, they're small. You want little angled tube steel or something like that. You want angles or tube steel, whatever you want. What we need to do to change that is as follows. We need to load something in. So I'll say, great, let's load a family and grab some structural steel so that's available to us. Then get some framing, some steel, and what can we find? Oh, what's our little, not a C channel, I want a little, what's the designation for tube steel? Plates, round bars. Structural T, welded flanges, channels, double angles. Is it an S?
HSS.
HS, thank you. Perfect. Tubing or sections. Let's go for sections. It's been too long since I've been hanging around in the steel handbook. Thank you. It's funny how, like, you don't use things every day. They kind of, you lose them. Okay, different sizes. So you want to pull in some sizes like, 4x4s or 6x6s, whatever it is that you think you might actually need. So let me get some of like some 4x4s or something like that. Again, you can choose different sections with different wall thicknesses, different sizes. The only penalty for going through and kind of choosing more is that it's a little more memory to kind of keep track of those things, but that's okay. 10 of them, no problem. 200 of them, you're starting to clutter up your memory and it'll slow things down. Okay, so I've got some new sizes to work with that I can use in any way. So I could make any sort of structural element, a column, whatever I want out of those. But what I want to do here is actually think about changing those diagonal elements. And that's verticals too. How about that? So what I'll do is for the truss, it has a series of properties. Okay, and you can make different properties, standard ones, or we could have a flat truss that has, fat elements, skinny elements, whatever you want. So let me even sort of duplicate this, and I'll say like tube, steel, diagonals, just so I have another variation to play with. And then what I'll do is for these diagonal webs right in here, say set the framing type and choose a specific element. So say 4x4 by like 3/8. Okay, that'll take care of the diagonal elements alone. Let's take a look at that. Okay, not too awfully bad. If I want to get those vertical elements too, what I'll do is in that same sense, come back here and edit that type. And I'll say the vertical webs. And do that same thing. So a well-articulated truss, you'd actually set everything. You'd set the top, the bottom, all those different pieces. But the nice thing about this truss is now that you've done this, you can now adapt the top chord or the bottom chord. You can get it to follow any shape, a rounded shape, a sloping shape, whatever it is. It'll kind of adapt to sort of follow. Yeah, 2 comments about trusses to watch out for. You'll notice that in an attempt to go through and just conserve the amount of graphical memory that it's taking up, it approximates the trusses. It doesn't do a really good job of coping and making sure all those elements fit exactly the way they need to fit, stuff like that. And it is connecting them at the analysis lines. It understands those as being connected. It's just not graphically representing it because it takes a lot of graphic memory to go through and do that. So if that's important to you, we can go through and fix that. In general, when people put in trusses, the first problem they have is though just that it looks really, really bad because you have these giant 12 by whatever members and they're just too big. As you get to smaller elements, it'll look better and better. But you still have that thing, you may want to clean it up. Okay, so there is a notion of something called coping, and let's see if I can show you what that is like. Anytime we have steel elements and they're not quite joined together, same thing with wooden elements, any sort of beam or structural elements, okay, it'll tend to stop showing you what's going on just as soon as these things intersect at all. As soon as they touch, it'll stop kind of graphically rendering it. And no worries. Yeah, it understands analytically they need to be touching, but what we can do is actually start attaching things, coping them together, and let's see if I can make that work for you. What I'm going to do is just do a tab so I can select that individual element. Okay, and once I have that tab, I can choose this option called coping. And coping, it does that thing where it cleans up. It like intersects, makes the steel really make the true connection it's supposed to be doing. So if I cope that, I always have to be careful about the order of things. First, select the element to be coped, and I think that's the thing I'm going to like somehow change the end of. Select the element to intersect it with. Okay, interesting. Okay, it did do a nice job down here, but it wasn't quite long enough. It didn't fill in the gap. No worries, we'll fix that. We'll come back and on this element over here, again choosing that, say, hey, what I would like to do, it's kind of graying it out, so I can't get to it very easily. I'm thinking about a way to go through and just fix the end justification. It's the hollow steel section. I want to basically overextend it so I can cope it and have it basically cut off in the way it is. I got to think about how to do that in a truss. I can definitely do that. That's there. I do it with any individual element. I just got to think about whether I can do that with a truss. So hold that thought right now. Okay, because individual beams I can definitely do that. And I can actually show you how we will show you how you can go through and add like seats and saddles and stuff like that to actually tie it together to give you, kind of clean up those connections. But maybe we'll get that right away. Let me show you how the other thing about how trusses work that's sort of interesting. Let's grab that truss. You can even edit the truss. The truss is defined in kind of an interesting way. You see that it really just has a top and bottom chord, and whether you're going to attach that top and bottom chord or you're going to draw that top and bottom chord, it doesn't really matter. For example, I can draw it But I can only have one top chord. Yeah, that'll make it have the shape you want it to. Okay, so watch out for that. If on the other hand, you want to have one that had 2 segments or 3 segments, if I wanted to have this be more, in that same sense, hang on here, zoom to fit. Come back over here. Let's take this, I'm again going to edit the profile. I can do the same thing down to the bottom. Nice sunrise truss. Let's see if this works. I don't know if it will or not. We'll see. Okay, so you can really start getting very, very custom in the shapes to kind of make whatever you want. So these trusses, fantastic in terms of how flexible they are. The cool thing is, especially if we're going to start thinking about some interesting undulating roof, because they can actually adapt to follow the roof form very easily. You can really have every truss have a custom profile that matches exactly what the roof profile is. And it'll take care of that. In a lot of modern structures, we do that. The computer models actually use them to actually do the manufacturing of the truss, because each of those are bar elements and exactly how it needs to be crafted to hold that shape will really just come out of the computer model and directly drive the steel fabrication. So, in a lot of very organic structures, it's about the only way to do it right now. So, we're doing okay in terms of these trusses. You got those trusses. As soon as you got one of those hanging around, you can go ahead and copy them as best you want. So, for example, I have one of them right here. In that same sense, I can grab it and copy it. Put one over here. Or, if you prefer, you can grab one and array it. That's another really interesting thing to do. Grab it. Say that you want to make a number of them. I'm going to make 6 of them. Let's see if I can do this from here over there. Can really make the entire series like that. So if you have a regular pattern, it also all the same sort of rules work. A truss just has really the same properties as a chair, a wall, anything else. So you can sort of array it and kind of do stuff like that. So let me pause right there for a second. How do trusses sort of feel to you? Got a sense of that? You got your answer? Okay. Basic idea of changing the cord material. That's looking good. Beautiful. Okay. Trusses may be one of your best friends in terms of doing this. Actually, let me talk about another thing that's sort of related. Along with these trusses, there's a whole notion of beams, roof beams. Have you been in these structures where there's a big curving ceiling and there's this big curving beam that's kind of following across? Often a glulam beam that's kind of following all these layers of wood that are holding the curve. You can do curved steel. Curved steel is kind of an expensive thing to do because it takes an awful lot of fabrication to kind of bend the steel like a big old W section to kind of hold the curve. That's kind of an expensive operation. Often we do that with, you see it with wood, something like that. But let's talk about how you can do that. Here's the deal. Let me cancel it out. If we want to go ahead and have any beam curved or following some special shape, let's show you how you can do it. I'll just take this out for a second. The deal is, if you can draw a line, a profile, or a line, a path, we can then have a beam follow that path. Okay, so it's really like in 110A, well, we did some stuff where we talked about extruding and sort of putting profiles along paths and sketching a profile along the path. That's actually how beams are done. That's really the mechanics of what's happening inside the software. So if, for example, we want to go through and have something follow a curving path, what we need to do is just sketch a line and then say extrude the shape of the beam along that. Okay, so let me show you what I mean. So for example, if I wanted to have some curving wooden beam kind of going between these columns, maybe it could be a single curve, maybe it could be some sort of swoopy curve that has an S shape or something like that. Here's what we got to do. We need to draw the profile that we're going to be following. Okay, and to draw a profile, drawing vertically is kind of hard to do. You need a surface to draw on. If you don't have a wall surface you can draw on, the best thing to do is actually make something called a work plane, which again, like one of those sketching surfaces that you can work with. We can put a work plane and sketch on that, and then use that to generate the shape. So let me show you what I mean. I will go to any old floor plan view, see if I can find, which one's my little structure? I think it's this one up here. Yep. Okay. I will go through and, actually I probably could use the grid line for that matter, but let me show you how to do it as a work plane, just so you sort of get the sense. We set work planes before. If you have a grid line, you can say set a work plane to the grid line. That actually does work. If you want to draw just a little bit off that, well, actually I should do it to the grid line. If you didn't have a grid line, what you can do is draw a plane and then give it a name. And then I can set my work plane to that named surface. Okay, and then I'd be drawing at that point. In my case, what I'm actually going to do is set it to be the grid, since I really want to put it right on top of the grid line. So I'll do something a little bit different. I'll say set it, and it was grid line G. Now, you may not see it. You can show it. It's interesting. Not even seeing it there. Well, we'll figure it out. I think that's my grid line G over there. We'll see. Okay, I want to now draw, oops. Hang on. Let me see in this view if I'm showing the structural columns. I think I'm just not seeing something. No, they're showing there. Why am I not seeing? So this is going on. Yeah. Looks like grid line G. Set the work plane. Grid G. Okay. Go to the east elevation so I can sort of see it from the side. I'm thinking about why I can't see them right now. If it's on grid G, I expect to be able to see the structural columns. Let me kind of do some other sort of things to see if there's something about the structural columns are there. Let me try one other thing over here. In terms of disciplines. No, again, thinking, not understanding. No. It looks like it's supposed to be there, but it's not. It says it's there. The column lines are there. Oh, it's going to occur to me in just a second. This will get you every time. The grid line is kind of currently set right there in terms of the cutting plane. I have to actually move it back so it's behind the grid line. That's kind of a really weird state that you could actually get into, that you could sort of be on a work plane where the work plane's actually behind your viewing plane. Is that too esoteric about what just happened? It's kind of the point where the camera was, I was basically standing too far forward, so I was not able to see it. If I go over to the east elevation now, I'll actually be able to see it. Okay, now I can see all those columns and what's going on in the background. Okay, so what I want to do is actually on that plane, I'm going to draw some sort of line, some sort of interesting line that I want to have my column follow. And what I can do is actually go through, I'm going to make some model lines. Model lines are really, what are they? They're just kind of things that we're going to use to, they're like little, I guess they're three-dimensional lines, but there's little paths that we can go through and use to go through and have things follow. So I can go and make some curving surface if I want to, like a big arc. And I could also go through and make some other sort of surface. So for example, or path, I could go through and make a spline if you like. So maybe coming up and going down and coming up and whatever it is. So let me go back to 3D and show you what I have in mind there. So I've really created two different sort of model lines there. I got that lower one, which is a spline. I have this big one up here, which is an arc. But at this point, if I want to go through and create some sort of beam that's going to go through and follow those, here's what you do. You say, great, I can get a beam. Looking pretty good. I'm going to choose a type, like whether it's hollow steel or whether it's a wide flange, whatever you have in mind. And what you do is you choose, you pick. And if you pick that surface, it'll go through and create a beam to follow that surface exactly. Now, again, don't necessarily advocate this. That's kind of a very expensive beam to go through and fabricate in terms of what's going on, but that's how you can go through and do it. Same thing down here. So I want to have one that sort of has this kind of funny curvaceous shape down there. I can do that. Nice thing is now, in theory, if I go move in the path, I get another version of the beam right there that I can kind of keep working with. Okay, so again, if you have some undulating curvaceous structure, don't be afraid of it. There's a way to go through and do it. Okay. It's expensive to go through and do things like that, but you know, you can go ahead and achieve it architecturally. So, sure, how's that part feeling? Beautiful? Okay. Let me give you one other thing to kind of think about tonight, because we can use this whole idea of the paths to really support almost any sort of structure. And really, in terms of surfaces, let me kind of just give you a sense of, I've heard people talking about kind of creating some very interesting surfaces. Let me zoom out a little bit. If you, for example, want to create some, it's like the waves or something that has some very interesting sort of profile to it, here's how you might approach the problem. You can say that you want to go through and create some reference planes. What I got to do is I got to sort of dictate or show what the surface is going to look like by drawing some profiles I'm going to link together. Okay, so you're going to have some curves that are going to determine the surface, and from that we can make really any surface we want. So what I'm going to do is actually just put down some planes. I can make these parallel to each other. I can even go through and have them curve at a slight angle if I want to. Whatever I have in mind. But let me just do this. I'm going to go through and say that that is going to be plane A. That's going to be plane B. And this is going to be plane C. And what am I doing? I'm just really giving myself planes to draw on. So super. I got my planes. We're ready to go. Let's go back out to 3D. I can set my work plane to plane A. Show it. See if I can find it. It's almost too big to sort of see what's going on. Maybe it's almost easier to just do it from the elevation. What I'm going to do on plane A is I'm going to draw a model line. So I'm going to draw something that looks like, this. Actually, that's a straight line. Do something a little more curvaceous. I'll go back over to architecture, model line. I am going to make some nice spline. So I have some sort of surface here that I'm creating on surface A. Okay. What I'm going to do now is actually set myself to plane B. Actually, it looks like I even sort of messed that one up in terms of A, B. So let's try that. Set reference plane A. I think I got it. That other one might have been on actually B because I switched. Looks like it's almost independent these days of which view you're in. I'm going to make another surface over here. That's my A. Let me switch over to B. Again, on B, I'll go through and make some model lines. Now for this, maybe I'll just make a simple arc. And then I'll finally switch over to C. And again, draw some model lines. Now what am I doing here? Ultimately you'd have some form you're trying to create. I'm just trying to create something that's a little bit unusual just to kind of give you a sense of how this works. So I got some lines. Let's go back over to 3D and show you what I actually have in mind. So over here, I got these 3 different surfaces kind of hanging out there. If I want to go through and create a surface that actually follows those different profiles and kind of gives me that undulating organic shape, what I can do is as follows. I can come back in and say massing in sight. Let me go through and create a mass. And what I'm going to do is actually just choose those 3 different surfaces. So what I want to do is, oh, can I do it inside here? I should have done that inside, I believe. Let's see if I can make it work out here. Will you let me create the form without it? Oh, I kind of messed you up. I should have done this inside the mass. Well, let me show you how it works within the mass. I hate it when demos go wrong, but we'll sort of get our way through it. Okay, set the plane. A. Beautiful. B. C. Again, what's messed up here, or what I messed up on, is just actually the order in which I had to do this. I need to actually sort of create the model lines within the planes, or within the mass to make it work. Okay. With that, I can now go through and choose 1, 2, 3. I can say, let's go ahead and create a form out of that. Okay. And it actually now has created this sort of very interesting undulating roof. You're thinking like, oh, that's looking pretty complex in terms of what's going on. But in some organic architecture, that's the sort of thing we have going on right now, is these really interesting organic surfaces. We'll say finish that up. If you want to go ahead and make that your roof surface, it's easy to do. You can go through and just into the roof tab. Say you want to do something by face. Choose something like the type of roof, whether it's concrete or whatever you want it to be, and actually just choose. Let me do it. Oh. Did I select it? Let me say clear the selection. I want to get within there. I want to be able to select that. Is it just thinking? It's just thinking. That's what it's doing. And hopefully not crashing. But what we're going to be doing is, if it doesn't crash, hopefully selecting that roof, using that kind of surface to go through and generate the face, and then underneath that, we can basically place trusses and attach them to the bottom of the surface. Is really where I'm trying to go with all this. So I will apologize if this is just going to get to be a slow, bad demo. Did it make it and I'm just not seeing it? It doesn't look like it made it. So hang on. Massing inside. Roof. Think about why it's not doing that, because again, I expected it should let me to do that, to go through and select a face. I can almost select any face. So think about what I have done that is so complicated that I can't do that in terms of generating the roof. Volume or surface area, that's okay. I'm good on all that. Roof. Select it, create face. Not sure why it's going to let me do it there. No. Enough of all that. We won't worry about that in terms of getting it completed today. But the point of it is that really, with almost any kind of shape, we should be able to go through and select that. So I hate to leave you right there where something didn't work right at the tail end of the demo, but it is basically you can choose any shape and basically attach trusses to it, and that'll be able to support any form. Yeah, we'll figure out why that's going wrong. I'm not seeing something which is stopping you from doing it, but we're going to figure out in terms of what we have to do there. Okay. Let us go ahead and break there. Let's talk about your check-ins for just a minute. So I met with some folks today. Most of you still have check-ins coming up over the next couple days. Please be ready coming into the check-in to kind of share your work so far. we're kind of just checking your progress in terms of moving along. So hopefully your building has kind of evolved a little bit from last week in terms of getting a little further and thinking about your overall architectural design concept. Hopefully your building is starting to think about that framing and how the structural system is going to be supported, so that when you come into the check-in, you can ask some questions about, oh, how am I going to frame this unusual condition or that unusual condition? So please take advantage of that time. It's a really good time to pose things and get some really nice individualized help when you're struggling with some things. So do that. The other thing to do is also, please remember to kind of post some things out there on that website every 2-3 days. Throw something out there. An article you found, something about something you're in the process of doing that you want to share, but kind of put some stuff out there. We're looking for you to kind of keep that thing going. So I know it's a busy week with all the midterms and stuff going through, but see if you can even if it's like 3 or 4 minutes worth of something, capture something you did this week and put it out there, just so we can kind of watch your progress as we go. Okay, beauty. Let us go ahead then and adjourn for today. I'll stick around and answer some questions, hopefully fix some of my problems and figure out why my computer and I aren't getting along today, but it's always some little thing. Hopefully the fact that I struggle with it will give you a little bit of hope as you struggle with it, that we all sort of do. It's just us versus software, but somehow we'll make it work. Okay, get yourself out of here. Thank you.